Hello students, today we are going to study very important chapter in mechanics, that is Newton's laws of motion. The Newton's laws of motion chapter has a very practical implication in our day-to-day life. There are three laws of Newton: first law, second law and third law. The first law of Newton is also called law of inertia. It does not define the force mathematically. It expresses the force only qualitatively. It gives only qualitative definition of force. It does not define the force mathematically. It does not define the cause of motion. Okay. Then second law of motion defines the force mathematically, and the third law of motion is also called action reaction law. Okay. Let's start Newton's laws. Newton's law of motion. There are three laws which we will discuss separately. This is first law. First law of motion, which is also known as law of inertia. And now second law of motion. And then in the last, third law of motion, which is also known as action reaction law. So these are the three laws of motion. Okay, let's start one by one. What is first law of motion? This first law of motion is also known as law of inertia. That is the first thing. And what is inertia? Known as law of inertia. Second, what is inertia? Inertia is a property of a substance by virtue of which a body tries to oppose in its state due to application of external force. due to application of external force. Mass is the measure of inertia. More is the mass, more will be inertia, more will be the capacity of the body to oppose the change due to application of external force. Okay. It is a property to oppose the change in its state or direction. Mass is the measure of inertia. Mass is the measure of inertia. The Newton's first law of motion defines the force qualitatively. Okay, it defines the force qualitatively. Defines force qualitatively. Qualitatively means it does not explain the cause of motion. It does not explain the cause of motion. For example, every body tries to continue in its state of rest or motion until and unless some external force is applied upon it. Okay. It defines the force only qualitatively. It does not explain the cause of motion. And force is essential to change the transit state of the body. Okay. For example, banking of the passenger towards the motion of bus, sitting in a bus on applying the sudden brakes, and to remove the dust particles from a cloth by shaking it are the few examples of Newton's first law. Okay. Now, dear student, let's see Newton's second law. The general statement of Newton's second law is external force acting on a body. External force acting on a body is equal to rate of change of momentum. Momentum means linear momentum. What is that? Mass into velocity. The linear momentum of system indicates the amount of motion present in the body. Velocity indicates the motion, and linear momentum indicates the amount of motion. Okay. So the statement of Newton's second law is external force acting on a body is equal to rate of change of momentum. Where momentum is mass into velocity. It is a vector quantity. When velocity indicates motion, the linear momentum indicates amount of motion. Force can be written as mass into acceleration. Okay. This Newton's second law explains the force mathematically. It explains the cause of motion. It explains the force mathematically, and it explains the cause of motion. Second law. explains force mathematically. It explains the cause of motion. The dimensional formula for force is mLT minus 2 and unit is kilogram meter upon second square. And if both mass and velocity is variable, then we write force like this: m dv upon dt plus v dm upon dt. In case of rocket propulsion, the mass of the fuel varies with respect to time. Okay. Now let's see for the third law also. Before going into third law, let's see one very important term, that is impulse. What is impulse? When a large force acting on a body for a short time interval, then product of force and time interval is called impulse. Okay. Impulse is equal to change in momentum. This is also called impulse momentum theorem. According to Newton's second law, F equal to dp upon dt. So dp is what? F dt. Whenever force and time curve is given to you, the area under force time curve in a given time interval gives us change in momentum, and impulse equal to change in momentum. This is equal to F delta t. This is called impulse momentum theorem. The unit of impulse is Newton second. This is the unit. Okay. And now, dear student, let's see Newton's third law. Let's talk about Newton's third law of motion. Newton's third law of motion is also called action-reaction law. To every action, there is equal and opposite reaction. Action and reaction always acts on different bodies. To be action-reaction pair, the nature of action and reaction should be same. Like if action force is electromagnetic in nature, then reaction force should also be electromagnetic in nature. Okay. This is called action-reaction law. The main statement is action and reaction always acts on different bodies, and nature of action reaction pair. Nature of action and reaction should be same. and as the action, anyone can be action or anyone can be reaction. As the action vanishes, reaction automatically at the same instant vanishes. Okay. As the action vanishes, reaction also gets vanished instantly. Now let's see illustration that will define more clearly action reaction. Look at this block of mass m. This weight is acting downward and this is the normal reaction exerted on the block by the contact surface. Now if somebody asks whether this Mg and N is forming action reaction pair or not, the answer is no. Mg and N is not forming action reaction pair, they are simply balancing force. Okay, why? Just understand. What is this Mg? This Mg is gravitational pull of earth. This is gravitational pull of earth on block. What is normal reaction? This is the contact force. Both are having different nature. Also, second thing, this Mg and N both are acting on the same body, so they are also not action reaction pair. Mg and N both are acting on the same body. And third thing, if the block is left from some height, then Mg will act, but N will not act. And what is the main property of the action reaction pair? If the action vanishes, reaction automatically gets vanished because we cannot differentiate between action reaction. Anyone can be action or anyone can be reaction. Okay. So Mg and N is simply balancing force. Okay. Let's see another illustration. Here are two blocks kept on a smooth surface of mass M1 and M2. Now what we are doing, we are applying some external force here. Because of application of external force F on block of mass M1, this M1 tries to push M2 and M2 tries to resist M1. Okay. So what happens? This M1 block exerts the pressure force on M2. This is written as N21. And the M2 block exerts the force on M1. This is written as N12. Now this N21 and N12 are forming action reaction pair. What is N21? This is normal contact force. Why normal? Because it is acting in normal direction. Why it is contact force? It is due to contact surface. Normal contact force on M1 normal contact force on M2 due to M1. And what is N12? Normal contact force on M1 due to M2. Dear student, this N21 and N21 are same in magnitude and opposite in direction. Okay, N21 and N12. So N12 and N21 are forming action reaction pair. N12 and N21 are forming action reaction pair. Okay. Hope you understood what is the property and how we classify action reaction pair. Now let's see some illustration based on this that will clear your fundamentals in more depth. A car of 1000 kg moving with a velocity of 18 km per hour is stopped by brake force of 1000 Newton. The distance covered by it before coming to rest is. Dear student, what is given in the question and what is asked? Velocity of the car is given, that is 18 km per hour. And also braking force is given which will produce deceleration, that is 1000 Newton. Mass of the car is given 1000 kg. What is being asked? Distance covered before coming to rest. So let us convert velocity from kilometer per hour to meter per second. So 18 kilometer per hour equal to 18 into 5 upon 18. This is conversion factor which we have used. So 18 kilometer per hour equal to 5 meter per second. Now, dear student, what is deceleration? Deceleration equal to braking force upon mass. 1000 upon 1000. This is equal to 1 meter upon second square. Now, distance table. Let us find the distance table by applying Newton's third law. Because finally, the car is coming to rest. So, final velocity of the car is 0. Initial velocity is 5 meter per second. V square equal to U square minus 2AS. This S is the distance traveled by the car before coming to rest. Okay. So 25 equal to what? 2S and S equal to what? 12.5 meter. This is the answer to our question. So option 3 is the correct answer. Option 3 is the correct answer to our question. Now let's see another question. A body whose mass 6 kg is acted upon by two forces 8ik plus 10jk Newton, 4ik plus 8jk Newton. The acceleration produced will be. Dear student, let us find total force. Force is a vector quantity. So how much is the force? This is 8ik plus 10jk plus 4ik plus 8jk. So total force is 12ik plus 18 jk. This is total force. And since mass of the body is 6 kg, so acceleration is what? Force upon mass. This is 12ik plus 18jk divided by 6. That will give you 12ik plus 3jk. This is the acceleration produced in a body. 2ik plus 3jk. Okay. So answer to the given question is option 4. So option 4 is the correct answer. Okay. Let's see another question. A block of metal weighing 2 kg is resting on a frictionless plane. It is stuck by a jet releasing water at the rate 1 kilogram per second, means dm upon dt is given at a speed 5 meter per second. The initial acceleration of the block is. Dear student, how do we write the force when mass changes? Force we write V dm upon dt. In the question, rate of mass flow is given. How much? This is given 1 kg per second. And what is velocity given? This is given 5 meter per second. So what is force? 5 into 1. This is 5 Newton. Now what is acceleration? Acceleration can be defined as force upon mass. Mass is 2 kg. So acceleration is 2.5 meter per second square. So answer to the given question is option 1. Now, dear student, let's see question based on impulse. A ball is moving with a velocity v, strikes a ball moving towards the ball with velocity u. An elastic impact lasts for t seconds. Then the mean elastic force acting on the ball is, we know what is force. Force is rate of change of momentum. And what is being asked? Force. What is the picture? This is the ball moving with velocity v. Let us assume mass of the ball is m. It strikes the ball. This is ball, which is moving with velocity u towards the ball. Now the time interval is given t. Since collision is elastic, now velocity of ball relative to ball is v plus u. Now this is in the frame of ball. In the frame of ball, this is the picture. Because collision is elastic, so ball is going with velocity u plus v, and again returning with velocity u plus v because collision is elastic. So what is change in velocity? In the frame of ball, this is 2 u plus v. If you take direction also into account, this is minus I cap. What is change in velocity upon time? This is 2 u plus v. This is magnitude upon t. And what is impulse? Impulse equal to change in momentum. Okay. Elastic. What is elastic force? Elastic force multiplied by mass. Okay. So force is 2m u plus v divided by t. This is the force. Now, dear student, the answer to the given question is option 1. Now, let's see another question. A cricket ball of mass 250 gram moving with velocity of 24 meter per second is hit by a bat so that it acquires a velocity of 28 meter per second in the opposite direction. The force acting on the ball if the contact time is 1 upon 100 of a second. Dear student, let's see. The ball of mass 250 gram, 250 into 10 power minus 3 kilogram, means this is 0.25 kilogram. The ball is moving with velocity 24 meter per second. When it is hit by a bat, so that it acquires a velocity 28 meter per second in opposite direction. During returning, the velocity of the ball becomes 28 meter per second in opposite direction. Now, what is change in velocity? Final minus magnitude of change in velocity. Magnitude of change in velocity. This is how much? 28 plus 24 in opposite direction. 8 plus 4, 12. This is 52. Okay. What is magnitude of change in momentum? This is equal to 52 into 0.25. This is equal to 13 kilogram meter per second. And what is force? Force is delta P upon delta T. So force is 13 upon 1 upon 100. This is 1300 Newton. 1300 Newton in the final direction of the ball. Okay. So answer to the given question is option 1. Option 1 is the correct answer. 1300 Newton in the final direction of the ball. Let's see another question. A body of mass 15 kilogram is moving with a velocity of 10 meter per second is to be stopped by a resistive force in 15 seconds. Then the force will be, the body is to be stopped in a time interval of 15 seconds. Body is to be stopped in a time interval of 15 seconds, okay, by resistive force. The mass of the body is 15 kg, velocity of the body is 10 meter per second. So, see here, final velocity will be 0. M is 15 kg. Resistive force is change in velocity, final minus initial, upon time. 15 will get cancelled. So answer is minus 10 Newton. This is resistive force. Magnitude is 10 Newton. Okay. So answer to the given question is option 1. So answer to the given question is option 1. Okay. Now let's see another question. Based on Newton's second law, a body of mass 2 kg. Dear student, this is a very good question. Remember, when force acts in x direction, then change in momentum will also come in x direction. If force acts in y direction, then change in momentum will also come in y direction. Okay. A body of mass 2 kg is moving in x direction, initially moving in x direction with velocity 2 meter per second. Means initial velocity of the body is 2 I cap. And on application of force 4 Newton, in which direction? Along y direction. Okay. For how much time? 4 seconds. Force is 4 Newton along y direction and time interval is 1 second. We know product of force and time interval is impulse, that is change in momentum. So dear student, change in momentum equal to mass into final velocity minus initial velocity. This is equal to product of force into time interval. This is J cap. Okay. So V final minus V initial equal to 2J cap. So dear student, what is V final? 2J cap plus 2I cap. This is V final. Okay. So magnitude of the final velocity is 2 square plus 2 square, that is 4 plus 4, that is under root 8. This is 2 root 2. Okay. Meter per second. This is the answer to the given question. So out of 4 options, the correct answer is option 1. Out of 4 options, correct answer is option 1. Okay. Now let's see another question. A force of 2 Newton is applied on a particle for 2 seconds. The change in momentum will be, this is direct formula based question on Newton's second law. What is change in momentum? Equal to product of force and time interval. This is 2 into 2. This is equal to how much? 4 Newton second. This is the magnitude of change in momentum. Okay. So out of 4 choice, the choice number 2 is the correct answer. Choice number 2 is the correct answer. Now let's see question again. A cricket ball of mass 150 gram is moving with a velocity of 12 meter per second. Is hit by a bat so that the ball is turned back with a velocity of 20 meter per second. The force on the ball acts for 0.01 second. The average force exerted by the bat on the ball. Now dear student, the ball mass is 0.15 kg and the ball is moving with velocity 12 meter per second. On hitting by bat, the ball direction changes and its speed becomes 20 meter per second in opposite direction. So magnitude of change in momentum equal to how much? Mass into 12 plus 20. This is equal to 32 into 15 upon 100. We are cancelling by 4. This is 25. This is 8. Again cancel by 5, 3 and 5. This is 24 upon 5. This is change in momentum. Dear student, what is force? Force equal to change in momentum divided by time. Time is 0.01 second. This is the force. So answer to the question is, this is 2400 upon 5. This is 4.8. 4.8 means 480. So answer to the given question out of 4 option is option 3. Option 3 is the correct answer. Option 3 is the correct answer. Okay. Now let's see one more question. A body of mass 20 kg is moving with a velocity of 3 meter per second, rebounds a ball with the same velocity. Okay. The impulse on the body. Impulse equal to what? Change in momentum. Since body mass is 20 kg, moving with velocity 3 meter per second, rebounding back with same speed, that is 3 meter per second. So what is impulse? Impulse equal to change in momentum. This is 20 into 3 plus 3 because it is in opposite direction. So 6 into 20. This is 120. Okay, Newton second. So out of 4 choice, the choice number 2 is the correct answer. Answer 2 is the correct option. So dear student, this was all about the basics of the Newton's law. In the second lecture, we will see motion of block on the surface and force, acceleration, tension, string and types of forces. Okay, thank you very much.